Now, I know you've laid awake at night the same way I have, and you've been wondering, Professor Foster, because you call me professor out of a mark of respect, which I deeply appreciate. Professor Foster, we've been doing transformations in one direction this whole time. Is there a way? Is it possible? I can't sleep anymore. I need to know. Can I do one transformation after another? Is there a way for me to do a transformation and then with that new transformation do another transformation? Is there a way for me to do a sequence of transformations? At which point I would say, please get out of my house. I don't know how you got in here. I'm just kidding. But yes, in direct answer to your question, yes, there is a way that we can do a sequence of transformations. And basically what we're going to do, that's exactly what we're going to do today, or that's what you should have done when this was assigned. It is literally exactly as I described it. You're going to do the first series of transformations, and that is going to give you x prime, y prime, z prime. Then, whatever this is, you're going to do a second transformation and get x double prime, y double prime, z double prime. So let's get started. The first way to get started is to do the pre-image first. So I've got -3, +7, so 1, 2, 3, 2, 3, 4, 5, 6, 7. -2, 1, so -2, 1. And then -5, 2, so 1, 2, 3, 4, 5, 1, 2. Alrighty. And so that will give me a triangle, and I'm always happy to work with a triangle because they only have 3 points. All right, so reflection along the x-axis. So for transformation 1, if you have a reflection along the x-axis, that means that you keep the x the same, but you take -y. So if it's a reflection about the x-axis, again, these points are going to be the same. The question is, how far away are they going to be from the x-axis? And they are going to be exactly the same number of points, the exact same distance that y is, just in the opposite direction. So the first transformation is going to give us, because x's are going to be the same, -3, -2, -5. But we've got all these y coordinates that have to become negative. So that becomes -7, -1, and -2. So let's see what the first one looks like. So we got 1, 2, 3, 2, 3, 4, 5, 6, 7. Then I've got -2, -1. Then I've got -5, 1, 2, 3, 4, 5, -2. So that is our first transformation. And under normal circumstances, we'd call it a day. We would say, all right, well, that's pretty good. So I'm just going to say that this is A and then A prime. But like I said, you've been awake all night dreaming. Is there a way that we can do another transformation once we've done the first transformation? So absolutely, yes, we can. So now we're going to do a translation of x plus 9 and x plus 2. See, I told you. Every now and then you're going to get this notation as opposed to what it usually looks like, which is this. Again, these two are exactly the same. It's just different ways of notating the same thing. But let's get started. So we're moving it over 9 and then up 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, up 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, up 2. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, up 2. And that is our second transformation that we have done. We inverted along the x-axis, we reflected it, along the x-axis, and then we translated it using x plus 9 and y plus 2. Now we can do this one of two ways. Now I just counted them out because it's the fastest way to do it. Now what I'm going to do is I'm going to do the arithmetic that will give me the actual points that I'm looking at. So 9 plus -3 is 6. 2 plus -7 is -5. I'm just going to do the x's first. 9 minus 2 is 7. Then 9 minus 5 is 4. And I'm going to add 2. Then I'm going to do plus 2 for the y coordinates. That gives me 1. And then 0. So do I have 6 minus 5? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Ah, almost like I planned it. And the rest of them I can probably infer. So yes, that is how we do the first sequence of transformations. You do the first one, get your first set of coordinates, then you do your second one, get your second set of coordinates. It really is that direct. All right, let's do another one because that's what the video is for. That's what I'm here for. So triangle GHI. Oh, I love these triangles. So 1, 1, 2, 3, 4, 5, 6. Negative 1, 3, negative 1, 1, 2, 3. And then negative 6, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, that gives me the triangle. Excellent. Translation along the vector 7, negative 5. Aha, see? This is what I was talking about. They go back and forth. This is the triangle one, and then they went back to the quagsire notation here. But they mean the exact same thing. So in this case, 7, negative 5 as the translation vector. That just means that I'm going to take x plus 7 and then y minus 5 for all coordinates, x and y. So let's just get started. I'm going to add them up here. I'm just going to do the numbers first, and then I'll do the picture. So 7 plus negative 1 is 6. 7 plus negative 1 is also 6. And then 7 plus negative 6 is 1. Now I'm going to go do the y's. There we go. I got to keep an eye on that. I apologize. Trying to keep everything centered with the camera. All right, I think this should work. All right, so y is going to be minus 5. So 6 minus 5 is 1. 3 minus 5 is negative 2. And then 6 minus 5 is 1. So now I'm going to plot the image. I've got 1, 2, 3, 4, 5, 6, 1. I've got 6, negative 2. And then I've got 1. Is that? Yeah, that's 1, 1. All right, there we go. So the first transformation is actually a translation and is a direct move from here to here. Let's verify this. So I've got 1, 2, 3, 4, 5. Hang on. 1, 2, 3, 4, 5, 6, 7. Okay, the 7 checks out. 1, 2, 3, 4, 5. The minus 5 checks out. We have done a successful translation. Now we've got to do a reflection on the line y equals negative 3. So that means 1, 2, 3. This is the line that we are doing the reflection of that. Wait. Yeah, y equals negative 3. Yeah. I had to stop myself just to be 100%. So again, with y equals negative 3, we've got a couple of different ways that we can do this. The first way is the numerical way, where what we have is x and y, and we're going to do a translation about y equals 3. And again, this is just my personal notation for the chemistry buffs. And if you have a translation of y across 3, what that does is it doesn't change the x value. But if you have y for general form y equals b, what it does is we do 2b minus y. And so we multiply whatever the new y-axis is by 2, and then we subtract the y-coordinate, whatever that was. So that's the mathematical way to do it. The alternative way to do it is to just count. So I'm 1 dot away here, 1, 2, 3, 4 dots away here. So 1, 2, 3, 4. Then I'm 1, 2, 3, 4 dots away. 1, 2, 3. Yeah, 4 dots away here. 1, 2, 3, 4 dots away here. And that gives us the image, but it doesn't give us the points. At this point, I can either count and calculate up these points here, which is a perfectly legitimate option, or I can actually just do this formula that I've been looking at because it's basic mathematical integer operations. Plus, x doesn't change, so that's 6, 6, 1. All right, that's half the work done already. So if if b equals 3, that means it's going to be 6 minus y. So whatever my y coordinate is, it's going to be 6 minus this y coordinate, whatever it happens to be. So 6 minus 1 is 5. 6 minus negative 2 is 8. and then 6 minus 1 is going to be 5. So let's see what that looks like. I got 1, 2, 3, 4, 5, 6, and then 1. Oh, 2b minus y, so that's 6 minus 1. Yeah, okay, I get it. 2b minus y. So g is 6, 1, so 2, 3, 4, 5, 6, 7, 8. Yeah, okay. 6 minus negative 2, so that would be negative 8. There we go. All right, that makes sense. So 6 minus 1 gives me 5. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Yep, there we go. Minus 5. All right, yeah, I got it. Okay. And then 1 minus 5. Okay, I forgot my signs. I rushed it, forgot my negative signs. So here we are. Those are the correct answers. All righty. I'd like to go a whole video without messing up in some way, but well, let's see how the cards play out. So I've got a rhombus with negative 1, negative 3, 1, 2, 3. 3, negative 4, 1, 2, 3, 1, 2, 3, 4. 4, negative 8, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. And then 0, negative 7, 0. 1, 2, 3, 4, 5, 6, 7. Alrighty. So I have got my rhombus. All right. Translation along the vector 4, 10. So what that means is I'm moving it to the right 4 spaces, and then I'm moving it up 10 spaces. Yeah, I guess I can do this a couple of different ways. I'm just going to add them up because I've got the points all the way up here, and it's better if we do the mathematical stuff first, then we do the counting first. Mostly because if I mess up the math, we can still count and move forward. So 4 plus negative 1 is going to be 3. 4 plus 3 is 7. 4 plus 4 is 8. 4 plus 0 is 4. All right. Now, we're going to add 10 onto all the y vectors. So, all the y coordinates, excuse me. This is the vector. We're adding 10 to the y coordinates. So 10 minus 3 is 7. 10 minus 4 is 6. 10 minus 8 is 2. And then 10 minus 7 is 3. So let's just see what this looks like. I got 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Alrighty. I've got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Alrighty. Yep, 7, 6. And I've got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. Alrighty. And then 1, 2, 3, 4. 1, 2, 3. Alrighty, thank goodness. So we actually did have a clean move over from 4 to 10. And just to confirm, I'm going to take the top left of each one. 1, 2, 3, 4. Okay, that checks out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That checks out. All right, so that's the first. That's the first one. Now we're going to do our second transformation, 90 degrees counterclockwise about the origin. All right, so that means that we're going to be that sort of thing. I mean, don't forget the sound effect. But x, y, 90 degrees counterclockwise about the origin. I think that one is, yeah, negative y, x. So x becomes negative whatever y was, and y just becomes what x was. So if y just becomes what x was, I'm dealing with a little bit of glare, so I got to move my position here. So if y becomes whatever x was, that's 3, 7, 8, and 4. And then x becomes negative y. So negative 7, negative 6, negative 2, and negative 3. All right, let's see what this looks like. We've got 1, 2, 3, 4, 5, 6, 7. 1, 2, 1, 2, 3. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6, 7. 1, 2, and then 8. and then 1, 2, 3, and then 1, 2, 3, 4. And there we go. Yeah, I think that's a pretty decent rotation after a translation. So, all right, I'm going to call this one good. All right, parallelogram. Ah, it's got to be a parallelogram. All right. Excuse me. Vertices at 2, -1, at 7, 1. Thankfully, they're quick to work around. 6, -2, and 1, -4. That's right, parallelogram. Rough parallelogram, but it's a parallelogram. Okay, reflection about y equals x. So that's the y equals x line. And so for y equals x, the transformation for that, for x and the y, I think that one is, yeah, y, x. So for the first transformation, we're just swapping these out. Oh, there we go. I'll recenter it on the camera here. So for the first transformation, we're reflecting it along the line y equals x. All that means is we're going to take x, we're going to make it y, and we're going to take y, make it into x, whatever it was. So so starting with c, that's -1, 2, because we're starting with 2, -1. Then we got 1, 7, because of that. That'll be -2, 6, because of that. And then -4, 1, because of that. All right, let's see what this looks like. So I've got -1, 1, 2. All right. I've got 1, 1, 2, 3, 4, 5, 6, 7. All righty. I've got -2, 1, 2, 3, 4, 5, 6. Then I've got -4, 1, 2, 3, 4, 1. All righty. Yeah, works out. Yeah, I think that works out pretty well. Again, my lines aren't entirely straight, but that is to give you hope that your lines don't have to be perfect because mine are not. All right, let's do with the second rule. Translation, -3, -7. All right, so that also is the same as using the non-Quagsire notation, -3, -7. So all we're going to do is we're going to take each of the x's, we're going to subtract 3. Then we're going to take each of the y's, and we're going to subtract 7. And we're going to move everything to the left and down, because that's what the -3 means, to the left. -7 means down. All right, so -1 minus 3 is -4. 1 minus 3 is -2. -2 minus 3 is -5. -4 minus 3 is -7. Now notice when I'm doing these operations and I'm doing these translations, I'm doing -3. I'm never doing -3. If you're doing a translation and you have a minus and you have a minus direction, that means that the x should become more negative. It's kind of a reality check. If you're doing a translation and your vector is -3, however you're doing it, like with this, if I did -3 and I ended up with 2, that means that the point went from -1 all the way up to 2. So that means that the entire image moved to the right. That should be a reality check that maybe you might have done the math a little bit incorrectly, because if it's -3, it means that it's moving to the left, and if it's -7, it means that it's moving down. So the x should be more negative, which all of these are, and the y should be more negative, which I imagine all of them will be. But let's just keep going. So that is 2 minus 7, which is -5. 7 minus 7, which is 0. 6 minus 7, which is -1. And then 1 minus 7, which is -6. I think that's what yeah. So let's take a look at what that looks like. So I got -1, 2, 3, 4, 1, 2, 3, 4, 5. And remember, this is a translation, so the reflection is already done. So 1, 2, and 0. -5, -1. So 1, 2, 3, 4, 5, -1. And then -7, -6. The line of reflection is getting in the way a little bit, but I think we're in good shape. So I got 1, 2, 3, 4. Wait, 1, 2, 3. That's 3. 1, 2, 3, 4, 5, 6, 7. That's 7. So yeah, there we go. That is our second transformation. So yeah, things are going pretty well so far. Finally, we've got triangles. So I've got 0, 3, 1, 2, 3, 3, 4, 1, 2, 3, 1, 2, 3, 4, and 1, 2, 1, 1, 2. Oh, that's a quite a dainty little triangle. All right, here we go. First transformation, 180 degrees rotation about the origin. So for the first translation, it is actually my favorite rotation. It is my favorite rotation transformation because it is just negative x, negative y. Whatever the points are, you just take the negatives. So L, 0, 3, that's 0, negative 3. M is 3, 4, so negative 3, negative 4. And then N, negative 1, negative 2. So that means 0, negative 3, 0, 1, 2, 3. Negative 3, negative 4, 1, 2, 3, 1, 2, 3, 4. And then negative 1, negative 2, negative 1, negative 2. So we continue to have our dainty triangle, but it is just rotated 180 degrees. I can beat that. Dilation of scale factor 2 using the origin as center. Well, if you remember, that transformation with scale factor of 2 just means that whatever x is, it's going to be 2 times x, and whatever y is, it's going to be 2 times y. So what that means, I'm just going to go through and multiply 2 times 2, and then I'm just going to go each point by each point. So 2 times 0 is 0, negative 3 is negative 6, negative 3 times 2 is negative 6, negative 4 times 2 is negative 8, negative 1 times 2, negative 2, negative 2 times 2, negative 4. Again, the scale factor of 2 simply means that I'm taking every single point, whether it's x or y, and I'm multiplying it by 2. So if I've got an x, I now have 2x. If I've got a y, I now have 2y. And that's how we're scaling it up at using the origin as the center. So again, 0, negative 3, I went to 0. Negative 3 times 2 is negative 6. Negative 3, same thing, negative 6. I got negative 4, multiplied that by 2 because the scale factor, negative 8. Negative 1 times 2 gives me negative 2. And then negative 2 times negative 2 gives me negative 4. So this is where I'm going to make the dilation. This is where the image is going to get bigger. So let's take a look at what that looks like. So 1, 2, 3, 4, 5, 6. Alrighty. Negative 6, negative 8. So 1, 2, 3, 4, 5, 6. And this is negative 8 because I've worked with these graphs for a fair chunk of the day. And then negative 2, 4, 1, 2, 1, 2, 3, 4. And it appears our dainty little triangle turned into a nice big hunk of triangle. So yeah, there we go. And those are your sequences of transformations. What you should remember to do is what I did with this very first drawing, but I forgot to do with every other drawing after that. So starting with it, so what you want to do is you want to start out with the image, which would be, you don't have to use A, I'm just choosing to use A. Then you use the first image, and then you want to specify the second image, even though you're still going to designate the points. There we go. Now we're on camera. Now we're on camera. So this is the image. This is the pre-image. This is the first image, and then this is the second image. Even though you aren't specifying it with these double apostrophes with the double primes, it never hurts to just add a little extra here just to make sure that everyone knows pre-image, image 1, image 2. So yeah, that is sequences of transformations.